Hi everyone, we are back and let's start to plot in 3D, and then also we'll do some ListPlot, ListLinePlots, and a cool function called show, essentially. So let's go ahead and let's define basically fun 2D or fun 3D. Let's do that. Let's do let's do something simple. Let's do x squared plus y squared, and we'll call it like that. And then I'm going to plot 3D again, same syntax, fun 3D. X goes from -10 to 10, and I could do Y goes from -10 to 10 as well, and I could plot, and voila. We can do some more with this plot. So I could do, again, plot theme, and then you see there's lots of different, I could do minimal, I could do, I like web. Oh, interesting. Yeah, that's nice. And we could also do color function, and we could do temperature map. So we could do here. So again, blue is low Z values, because again, we're plotting in X, Y, and then Z axis here. So I could do, I think you could even do reverse temperature map. I think that there is a way, color function, temperature map, or thermometer. I think it's temperature map. Let's do reverse, maybe. So we could do the opposite as well. Nah, it's not going to allow us to do that. Sometimes you can do a reverse temperature map, but anyways, so cool, nice. So that's web. I could do detailed, and then get those values. I could do changing my function. I could do cosine of x squared, and then we can see what we got. Then I can see a different function. I could rotate this around. So pretty cool function when you're plotting 3D, and you can kind of visualize that here in Mathematica with Plot3D. Now, most of the time, we're going to be importing data, working with data, and we are going to be looking at plotting data. So instead of plotting a function and setting bounds of x, y, z, all those good things, we can instead plot our raw data set. So I'm going to do R1. So let's say random. I'm just going to do random data set, random integer, and I'm going to do from -10 to 10. And then let's do that for 100 times. So that's R1. I can do R2, which is going to be, I can now do random variate. So this is randomly pulling from a normal distribution where my mean is 0 and my standard deviation is 0.1. And I'm going to do that for 100 random steps. I can do the same thing here, but I could change my R3. I can change my standard deviation to 10, so that's going to be very different. And I could even do R4, where it's a little bit in between. So R4 is just going to be 1. Mean at 0, so we can kind of see all those values. So I can plot those right now. So I could do ListLinePlot of R1. But this is assuming that each data point in R1 corresponds to 1 second or 1 value here. So usually we want to explicitly plot as a function, these values R1. So let's do R1, 1 to 10. So we're plotting this value here at 1 second, et cetera, et cetera, et cetera. A lot of times we want to figure out and plot this as a function of the x variable. So for example, time. Let's just do T1. I'm going to do table from I goes from 0 to I goes from 0 to 100. And I'm going to transpose T1, because that's my x coordinate, and my y coordinate is R1. Shift enter. Uh-oh. Why is that not working? Let's do length of T1. Let's do length of R1. The lengths are different. They can't be transposed. So because I'm starting from 0, now I need to do this. Now this will work. And now I can plot this as a function of time. So ListLinePlot, R1, T1. I could also do ListPlot. So ListPlot like this. I can do, like here, ListPlot, and I could do joined true. So I can join and create a ListPlot, or I could do, like I said, a ListLinePlot, and I could do those things. And I could do all those fancy functions that we were looking at previously. But again, that's not going to make a huge difference. I could also plot all of these together on the same graph. So I could do, for example, R1. I could do comma, 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 because we're going to do R1, R2, R3, 4, and I'm going to do plot style. I'm going to do basically just very simple blue, red, green, purple. So you can see those values here, and they're all plotted on the same plot. And I could do plot range all to make sure everything's there, but we're good. So you can do that, but maybe I want to instead look at and compare, you know, our 2, 3, and 4 are basically have the same mean but different standard deviations. So let's say I want to see the fluctuation in that data set. I could just remove this one, and then I could kind of see some of those values. But let's say, for example, that I am, let's say I'm plotting it one at a time for some, you know, reason or rationale. So let's say ListLinePlot of, let's just do this, and I'm going to make this, I'm just going to call this blue. So I'm going to just call this LLP1, or actually LLP2, and we could do, okay, copy here, we'll do it for LLP3. So I create variable, and I got to use these values here. I'm going to call this red, and then I'm going to do LLP4, and then, because show is a very important function in Mathematica. So let's say, for example, I do show LLP1, or LLP2, LLP3, LLP4. This is not visually attractive, right? The reason why is because the first plot, that sets my plot range. So this has the widest range. So actually I want to do LP3 and LP2 here. Now I could see everything. So that first plot you put in, it's going to use that plot range implicitly. So sometimes you're going to have to adjust this so that you can see all the data sets together. But here I can clearly see, again, big fluctuations in that data set, small here, and even smaller for the blue. So another way that we're going to see in the next video of how to look at distributions and how to look at variability in data sets is with histograms. And actually, we could do that right now. We could combine this. I think we're still good in the video. So let's look at let's do a look at a histogram for R1. That was our random data set. And you see histograms are plotting essentially the counts of each of these values here. So our x-axis is our measure n. So again, in R1, it's counting how many times do I see 4, -7, or all those values, et cetera, et cetera, et cetera. I can change, and I could do this automatic binning. I could look at, instead of counts, I could look at probability. I could look at my PDF, my pair distribution function. I could look at lots of different kind of values. I could change this to 2 bins. I could change this to 40 bins. So you can change essentially that look at that histogram here. So you'll see that this is pretty random, but if I look at R2, I do automatic, this is starting to look more Gaussian. And we can actually go ahead and actually see a little bit further down here. So I can do a histogram of R2, R3, R4. And we're going to look at this all automatic, all PDF. And we are going to look at plot range all. And I'm going to look at, actually, let's just set their data set will be there. So we can see here, again, actually, let's set some colors. Plot style. Actually, so see, plot style is not a function here, so we need to do histogram style. Actually, who do we not have? Well, let's use a chart style. Chart style. See, because it's histograms, it's technically classified as a chart. So blue, red, green. So my blue is that, again, super small Gaussian. Red was 3, large, you know, see, very widely distributed. And then R4 is the in-between one. So, makes sense. I could also do smooth histogram of R2. So, looks a little bit like that. So that would be like smooth histogram looking at basically this chart right here. Actually, smooth histogram, let's do automatic and then PDF, just so it looks a little bit better. But yeah, looks good there. I could do histogram 3D. So I could take, basically, I could transpose, not transliterate, transpose as my X and Y coordinates R2 and R3. And I could look at that 3D histogram. I could look at R1 and R3. I could look at R2 and R4, et cetera, et cetera, et cetera, et cetera, et cetera. So if you actually add the numbers, it'll be even better and easier to do that. I can look at a density histogram. So density histogram. again, X and Y coordinates. So transpose, not transliterate, transpose. So I could do, again, R2, R3. So you could look at the density histogram right there. You could also look at, paired density histogram. So I could look over here. I could do paired histogram. Paired histogram, and I could just do, for example, I could compare R2 and R3, and we'll see a big difference there. Thinking, and you see, look at that. Very, very wide, very, very distributed, and then our pretty, small Gaussian there. So you can get a side-by-side comparison. You can do kind of cool things there. So that's histogram, that's ListLinePlot, that's Plot3D. So we will go ahead and continue on with all the different plots, as you can see here. And then next time, we'll get at it. All right, see you in the next video. Thanks. Bye.